Chapter 23, Equipping Items on the Player. In the previous chapter, we managed to get the player's grubby hands on the dungeon items. As a result, the player is now a sort of janitor that can run around, organize and rearrange the items found in the dungeon. But we haven't really given him any way to use the items. In theory, we could let him use the items this way, just by moving and dropping the items. If the items functioned as traps that would ensnare or damage the monsters, lures and bait that would attract the monsters, obstacles that would prohibit the monsters from passing, or scarecrows that would repel the monsters. Now, we want to let the player equip items, to wield weapons and to wear armor. To achieve this, we'll introduce a container into his bag, but organized differently. It will contain peg slots that indicate the location of worn items, that is, hands, legs, feet, and head. It will be the worn map, a map of which items are currently worn. The slots are formed by the slot enumeration we introduced earlier with the object class. Note, maps in computer lingo are not spatial geographical maps. Instead, there are associations between a list of keys and a list of values those keys map to. For example, mapping equipment slots, the arms, head, feet, to worn items, gloves, helm, and boots. Whenever the player puts on or takes off a wearable item, it will be transferred between his bag and this equipment map. During combat, our code can then inspect the worn map to see with how much power his weapon will hit, or how effective his armor will be in reducing the damage he takes. To implement this, we must explain the worn slot enumeration and introduce the worn map container in the game model. We must have commands to equip an item and to unequip an item. We must integrate the equip command with the bag inventory, and we'll need a user interface screen for the worn equipment, partly to support unequipping, partly to show the player what he's wearing at a given time. We must adjust the hit command damage mechanisms to involve weapon damage from any wielded weapon and damage reduction by any worn armor. The worn model. This here is the slot enumeration earlier from chapter 21. We already used it there to tag our objects to indicate whether and how they could be worn. We'll now use this enumeration as peg keys in the worn map. You might notice something peculiar is going on with both hands and main hand. More on that later. The not worn is of course for other kinds of items not supposed to be worn. And then we'll need a class for the worn map container model itself, the 23 worn.ts. Let's look at what this worn class offers. It has the expected methods to add and remove objects. It has methods to query whether we have a certain slot equipped and to get any object equipped in a given slot. Finally, it has methods to check whether a given object or slot can be equipped. These are guards against wrong usage. That's why they throw exceptions. Of note is that worn currently has no protection against equipping an item on top of another one. Instead, the prior item would just vanish. A better design might be that add and remove would instead be try add and try remove. They could then return false if we try to equip something on top of something else. Similarly, remove might complain if we try to remove an item we are not carrying. We won't exactly do that because we instead take care of those things in the commands we will make to operate on this model. But it's an idea to consider. Yet another idea would be that equipping automatically swaps out earlier equipped items. But all that is concerns for the commands, not the model. As we did earlier with the inventory bag, we must integrate this new model part into our existing game model. So we integrate the one model in game interface and game 5, which we clone from game 4. So we'll now create 23 game model 5.1.ts. And we can fix up the earlier models with this. We must make the commands for equipping and unequipping. They'll take care of verifying proper arguments and emit error responses to the user if he tries something funny. It's for this user feedback that we want to handle this in the commands and not in the warn model. So 23 where command looks like this. So the where command checks 3 prerequisites and completes the equip action if those are satisfied. If they're not, the user instead gets a flash error. And the checks concern these things: whether the object can be equipped at all, whether we're already wearing something in that slot, and again a better implementation might be to automatically swap out whatever was equipped before. Note this choice would affect whether swapping worn items counts as 1 or 2 turns. And finally, whether we are already wielding a weapon. You might wonder why the weapon check is not already handled by the second wearing check. It actually might be, but traditionally, weapons are often weird special cases where you can either wield a single two-handed weapon with both hands, or one weapon item or a shield in each hand. Therefore, it's not enough to just check a single weapon slot. There are various ways to implement two-handed weapons. One way is to have a separate slot.bothhand slot, which may not be equipped at the same time as slot.mainhand and slot.offhand. The equip command highlights a choice in coding style. It's been split into 4 functions, the main execute function and 3 utility functions. If we didn't split it up, it would clock in as 30 lines of code. By splitting it up, it instead grows to 40 lines of code, which achieve no more work or features. So one might wonder, why would we be wasting 40 lines when 30 lines would do? One answer is that you might very well just write it as that single block of 30 lines. But this is what we gain from splitting it up. This way, execute becomes a sort of menu overview, which gives a high-level view of what our equip command does. That it does a wearable check, an already worn check, an already wielding weapon check before it does the simple back to worn swap. And the 3 check methods each isolate and concern a single feature and behavior. You can read them in isolation and verify exactly what they do and how they do it. In particular, you know that any change to any feature belongs precisely in those methods. If you want to remove or change them, there's one precise place this happens. Most importantly, the control flow becomes very easy to follow. We can easily see that each of the checks has the ability to abort the equipping action. The actual effect of the command, the item swap, stands out and is uncluttered and simple. And if you want to extend and complicate the equip command further, this existing structure hints you might do so with further isolated methods hooked into execute in the same way. To sum it up, this way of splitting it up makes the code much easier to work with. If we view ourselves as people whose situation is to continuously modify this code, the focus on 30 lines instead of 40 only makes sense if we instead view ourselves as the guy who has to write this code once and be done with it. Then we might have the belief it would be faster to write only 30 lines of code. Note that the goal here is not to split up the code as much as possible. If you really did that, the code would again become unreadable, scattered into innumerable fragments. Our aim with splitting it up is to express its composing features as clearly as possible, particularly to each modifying or extending those features and to avoid separate features accidentally affecting each other. End of digression or rant. The unequip command. For the unequip command, we act off a chosen slot. Our checks are somewhat simpler. We just need to check that the slot refers to something actually equipped, which we can unequip. So it looks like this. Though we now have the appropriate commands, there's not yet any way we can use them. We'll need some other code to be executing these commands. The equip integration. The obvious place to integrate the equip command is through the inventory screen somehow. We can't do it directly on that screen though. We had an earlier discussion when we implemented the drop item command, where we concluded that we would want to do several possible things with the items, and so we came up with the item screen menu. So in that 22 item screen, we now make these changes to allow the user to activate the equip command by pressing the W key. To test the wearing equipment features, we now have enough to start testing some of our equipment features. To run it, we'll first have to clone the 22 Builder 2K into 23 Builder 2L. We'll update it to use the game 5 instead of game 4, and then we need the index 23 one. And with that, we've integrated our equip command. We can equip items when the game is running. If we were to run our program now, then the item menu screen triggered from the inventory screen would look like this. But we don't have any place to integrate our unequip command yet. Given that we can't yet do anything for our unequip command, let's instead focus on providing the user with a way to see what it currently has equipped. We'll make an equipment screen, which we insist on calling the worn screen. It will run through all possible equipment slots and draw a label for each of them. Some of them will currently have an item equipped and some not. The slots with equipment will paint in yellow. The empty ones will paint in grey. The grey slots can then serve as inspiration and ambition for the player. Oh, if I ransack the dungeon, one day I might be able to equip an item even in slot X. For the equipped items, we will of course show their names. With our new worn screen ready, we must provide a way for the player to trigger his equipment inventory. So we add the following part to his actions in 09 pass player. Note that such information actions do not count as turns. You could make a game where inspecting information would count as turns, but it's not traditionally done. So if we run the game again, we can now see what we have equipped. The unequipping command. Now that we have an equipment screen, we also have a place for our unequip command. We can integrate it into 23 worn screen like this. And voila! We can now equip, view and unequip. But it's all just a fashion statement, since the worn items don't do anything yet. Effects of worn items in combat. Our intention with providing the player with the items to equip was to give him a way to get stronger and more powerful. We must introduce some ways the worn items affect the player's power. We'll do so by modifying the hit command so that the worn class somehow provides variable inputs to it. The worn weapons should control some sort of hitting damage power, and the worn armor should reduce damage taken to some degree. First, let's extend the worn class with some calculations that pool together the numbers from the worn items. We'll calculate a kind of armor class, AC, and a number for weapon damage. Our weapon number is simply the level of the weapon plus 1. We make it so that weapons from level 0 has the damage number 1. The number is a roll range from 0 to n, so the average damage will be half that number. Note that as the code stands, stronger weapons have a much better chance of hitting because 0 rolls will be rarer. Those are the misses. And beware, we add the 1, so for example a level 3 weapon will hit for 2, a half times 3 plus 1. We then modify hit command to work like this. We want to give the player some hints about these mechanisms, so we will add these numbers to the dashboard. In the render stats method in 07 draw map, we adjust these bits. The labels are attack power, armor class, and effective armor or something. Armor mechanics background. Traditional Dungeons and Dragons issues. Our armor class design is not the traditional armor class from fantasy games. There are a number of design schools for these. A very traditional one is D20 based. In those, the enemy's attack dice must hit above your armor class. The higher the armor class, the smaller the chance to roll a higher number. In the worst case, the defender would have a maximum armor and only a critical hit of 20 would be able to penetrate and do damage. The horrible thing about such traditional armor class is that the final points, for example armor class 17 to armor class 20, would increase your defense ridiculously. For example, going from 18 to 19 would reduce your damage to half, an increase of 100% for a single point. Armor class creep. Another problem concerns the player collecting armor class directly. If the player could find items of increasing power, where he could keep adding small integers to his armor class, the number would continue to grow and grow and grow, 50, then 100, then 200, and so on. It would be difficult to both make the initial small armor class have any effect, and to also assign meaningful effect to those ever higher 100, 200, and so on numbers. One way to escape that is to introduce a level of indirection, where the directly collected armor numbers are used to indirectly buy armor class numbers at diminishing returns. For example, the first point of armor class could cost 1, the second would cost 2 points, the third would cost 3, and so on. This way, for an armor class of 10, you'd have to pay 55 points. This doesn't solve all, but it would reduce the speed with which armor class would run amok. Another approach. Alas, the main flaw with this approach is that we eventually would reduce damage taken to almost nothing. The flaw lies in that it subtracts damage. Because of this, we'll take a different approach. Instead, our armor class will reduce damage by a factor. That is, we'll divide the damage with a fact to make it smaller, instead of subtracting from it to make it smaller. This scales in a much better way, because even though we divide the damage, there will still be some left seeping through. Aiming for balance. We're also on another different mission here. One of our overarching missions is to balance the game. We are concerned with how many hit points monsters have, how much damage they do, and how much damage creatures take. At the same time, we're aiming to let the player grow in power. To balance this, we can pick some target numbers to aim for. We could decide that we expect the player to eventually reach armor classes of 10 on level 1, of 20 on level 2, on 30 of level 3, and so on. In symmetry, we could then decide that monsters on level 1 will hit for 1 on average, for 2 damage on level 2, and hit for n on level n. If we keep the player's hit points pool unchanged, we can see that, for example, an armor class of 50 would have to be in balance with an average damage of 5. The obvious way to do this is to let the armor reduce the damage by armor class divided by 10. That is, an armor class of 50 would reduce by a factor of 5, an armor class of 30 would reduce by a factor of 3, and so on. This is not a locked design. Currently, it would depend on the player never getting more hit points. For power sense and utility, we may be interested in letting the player gain some extra hit points, and balance that into it somehow. For example, growing from 20 to 100 hit points. However, it may be easier to keep a sense of the numbers and the balance by not letting hit points grow extreme from 20 to, for example, 10,000. In general, if you let numbers grow too high, you'll give yourself the extra burden of having to make them readable for the player, for example by switching to scientific notation. World of Warcraft suffers from this problem. But for now, let's stick to the basic design. With a target armor of class of 10, 20, 30, we can allow the player to be expected to collect, for example, 10 different pieces of armor per level, each contributing with an average armor class of 1. It might also be 5 pieces of armor that give 2 armor class each, or maybe each level just provides 5 expected armor class instead of 10.